Imagine a well-trained dog taught to fetch a specific ball. Now, imagine the ball slowly changing color, shape, and size over time. Eventually the dog might not recognize it as the same ball anymore. This is similar to what happens with AI model drift. AI models are trained on data. This data represents a snapshot of a moment in time. As the world changes, so does the data. This means the model's performance can decline over time. Like the dog, it no longer recognizes the patterns it was trained on. In software testing, AI models play a crucial role in automating tasks. They can identify bugs, predict defects, and improve overall software quality significantly. However, these models are vulnerable to drift. As software evolves, the initial training data becomes outdated. New features, code changes, and user behaviors all contribute to this phenomenon. This drift can lead to inaccurate test results and missed bugs, undermining the reliability of the testing process. Understanding AI model drift is crucial for maintaining the effectiveness of software testing tools. By recognizing the causes and consequences of drift, developers and testers can implement strategies to mitigate its impact and ensure the accuracy and reliability of their testing processes. This proactive approach is essential for delivering high-quality software in today's rapidly evolving technological landscape. AI model drift poses a significant challenge to maintaining test accuracy and reliability. As models drift, their ability to accurately predict outcomes diminishes significantly, leading to unreliable and inconsistent test results. This decline in accuracy can manifest in several ways, impacting different aspects of the software testing process. One major impact is the increase in false positives. These occur when a test incorrectly flags a piece of code as faulty when it is, in fact, working correctly. This can lead to wasted time and effort as developers investigate non-existent issues. Conversely, drift can also lead to false negatives, where genuine bugs go undetected. This is a more serious problem as it allows defects to slip through the cracks and potentially impact end users. Furthermore, model drift can hinder the ability to effectively prioritize testing efforts. As models become less accurate, they may misjudge the severity of defects or fail to identify critical areas that require immediate attention. This can result in valuable resources being misallocated, potentially leaving significant bugs unaddressed. The consequences of inaccurate testing due to model drift can be far-reaching. It can lead to software releases with undetected bugs, impacting user experience and potentially damaging a company's reputation. In extreme cases, it can even lead to financial losses or safety issues. Therefore, addressing model drift is not just a technical necessity, but also a critical business imperative. Early detection of AI model drift is crucial for minimizing its impact on software testing. Model drift occurs when the statistical properties of the target variable change over time, leading to a decline in model performance. By identifying drift in its initial stages, teams can take corrective action before it significantly affects the accuracy of their testing tools. This proactive approach ensures that the AI models remain reliable and effective. Several methods can be employed to detect drift, each offering valuable insights into the model's performance. These methods range from simple statistical tests to more complex machine learning techniques. One approach is to closely monitor the performance metrics of the AI model over time. This continuous monitoring helps in identifying any deviations early. This involves tracking key indicators such as accuracy, precision, and recall. These metrics provide a quantitative measure of the model's performance. Any significant deviations from the baseline performance established during the model's training phase could signal the onset of drift. Regularly comparing current performance to the baseline helps in maintaining model integrity. Visualizing these metrics through graphs and charts can help in identifying trends and anomalies. These visual tools make it easier for teams to spot issues quickly. Another effective method is to implement a system for collecting feedback from testers and developers who use the AI-powered testing tools. Their hands-on experience can provide early warnings of potential drift. They are often the first to notice any inconsistencies or unexpected results in the testing process. This qualitative feedback is invaluable for early detection. This feedback loop can provide valuable anecdotal evidence to supplement the quantitative data gathered through performance monitoring. Combining both types of data gives a more comprehensive view of model performance. Furthermore, A/B testing can be employed to compare the performance of the current model with a previous version or a newly trained model using updated data. This method helps in validating the effectiveness of the model. This allows for a direct comparison of their effectiveness in identifying defects and predicting outcomes. A/B testing provides clear evidence of any performance changes. Significant discrepancies in their performance can indicate the presence of drift in the older model. Identifying these discrepancies early can prevent larger issues down the line. By combining these methods, development and testing teams can create a robust system for early detection of AI model drift. This multifaceted approach ensures comprehensive monitoring. This proactive approach allows for timely intervention, minimizing the impact of drift on the accuracy and reliability of their software testing processes. Ultimately, it ensures that the AI models continue to deliver high-quality results. Section 4. Staying ahead of the curve. Correcting drift in software testing tools. Once AI model drift has been detected, it's essential to take corrective action to ensure the continued accuracy and effectiveness of your software testing tools. Ignoring drift can lead to inaccurate test results, which can compromise the quality of your software and user experience. Addressing drift involves a combination of strategies, including retraining, recalibration, and potentially even redesigning your models. Each of these strategies has its own set of challenges and benefits, and the right approach depends on the specific circumstances of your software and its environment. Retraining your models with fresh data is often the most effective way to combat drift. This process involves updating your model with new data that reflects the current state of your software and the environment in which it operates. This involves gathering new data that reflects the current state of your software and the environment in which it operates. The data should be comprehensive and cover all aspects that might influence the model's performance. This could include data on new features, user interactions, code changes, and any other factors that might influence the model's predictions. By incorporating a wide range of data, you can ensure that your model remains robust and accurate. In some cases, simply recalibrating your existing model might be sufficient. This involves adjusting the model's parameters or weights to better align with the current data distribution. Recalibration can be a quicker and less resource-intensive approach than full retraining, especially when dealing with minor drift. However, it's important to monitor the recalibrated model closely to ensure it continues to perform well. However, if your model is severely outdated or the underlying software has undergone significant changes, you might need to consider redesigning your model altogether. This is a more involved process but can yield significant improvements in model performance. This involves revisiting your initial assumptions, exploring new algorithms, and potentially even incorporating different data sources to create a model that's better suited to the evolving landscape. Redesigning your model can be a complex task, but it can also provide an opportunity to innovate and improve. Remember that correcting drift is not a one-time fix. It's an ongoing process that requires continuous monitoring, evaluation, and adjustment. By regularly reviewing your model's performance and making necessary updates, you can ensure that your software testing tools remain effective. By embracing this iterative approach, you can ensure your software testing tools remain accurate, reliable, and effective in the face of evolving software and changing user behavior. This proactive stance will help you stay ahead of the curve and maintain the quality of your software. Section 5. The importance of upkeep. Maintaining your testing arsenal. Maintaining the effectiveness of your software testing tools goes beyond simply addressing AI model drift. It involves a comprehensive strategy that ensures your tools are always in peak condition. It requires a holistic approach that encompasses regular maintenance, updates, and a commitment to continuous improvement. This means not only fixing what's broken, but also proactively enhancing your tools. Just like any other tool, your testing arsenal needs regular upkeep to function at its best. Neglecting this can lead to inefficiencies and potential failures in your testing processes. One crucial aspect is keeping your testing tools up to date. This is not just about having the latest features, but also about ensuring compatibility and security. This includes installing the latest software updates, patches, and security fixes. These updates are essential for maintaining the integrity and performance of your tools. These updates often contain bug fixes, performance improvements, and new features that can enhance the accuracy and efficiency of your testing process. Ignoring them can result in missed opportunities for optimization. Neglecting updates can leave your tools vulnerable to security risks and compatibility issues. This can compromise the entire testing process and lead to significant setbacks. Equally important is regularly reviewing and refining your test cases. This ensures that your tests remain relevant and effective as your software evolves. As your software evolves, so too should your tests. This dynamic approach helps in identifying new bugs and issues that may arise with new features. Outdated or redundant test cases can lead to inaccurate results and wasted effort. Regularly updating your test cases ensures that your testing efforts are always aligned with your current software state. Review your test suite periodically to remove obsolete tests, update existing ones, and add new ones to cover new features and functionalities. This keeps your testing process robust and comprehensive. Furthermore, it's essential to foster a culture of continuous improvement within your testing team. This culture encourages innovation and keeps the team motivated. Encourage team members to share their knowledge, best practices, and lessons learned. This collaborative approach can lead to significant improvements in your testing processes. Conduct regular training sessions to keep everyone updated on the latest testing techniques, tools, and technologies. This ensures that your team is always equipped with the best practices. This ongoing learning and development will help your team stay ahead of the curve and maintain a high standard of testing excellence. Continuous education is key to adapting to the ever-changing tech landscape. Remember that maintaining your testing arsenal is not an optional extra but an essential investment. It's a critical component of your overall software development strategy. By prioritizing regular upkeep, you can ensure your testing tools remain effective, reliable, and capable of delivering accurate results, ultimately contributing to the delivery of high-quality software. This commitment to maintenance will pay off in the long run by ensuring the robustness and reliability of your software products.